Welcome to Unit 11, Day 4. Today you will be working on kind of just picking up the basic concepts of finding the area of a non-traditional looking shape with some holes in it. It's going to be made up of several pieces. Your goal is to figure out the area of the region that is shown on your paper. Suggested items, you'll need your handout. The handout should say day 4, or it might even say guided practice for a Unit 11 project. Calculator would definitely help. Rulers and colored pencils are recommended, but not necessarily required. All right, your goal is to basically take this shape and break it down into regions that are triangles and rectangles. Once we do that, we can calculate the area of each part and then find the total area. So I'm going to suggest when you look at this picture, thinking about finding the area of large triangles and rectangles that cover up the whole picture. Now, I'm going to draw one on here, just so you can kind of see the pattern. And I want you to notice how the rectangle I'm drawing covers up more than the original picture. So the area of this rectangle is definitely larger than the area of the region it covers. So how much larger? Well, there's a hole at the top that's 5 feet by 6 feet wide on this rectangle. We'll have to subtract that region out. So I'm going to put a minus sign next to that area, just so we know we're going to have to subtract that out of there. And we're going to kind of use a similar idea for this region down below where it says hole. I'm going to subtract that out because the rectangle that I'm drawing has a larger area than the original picture. So what are the dimensions of this rectangle? Okay, so the base of this rectangle is not necessarily provided directly. The height, however, is provided. There is a typo on this, so I'm going to change mine to feet over on the right, and I don't know if that's fixed on yours or not, but if it's not, go ahead and make that adjustment. Look down below and you should see region 1 has a height of 17. Now, where did we get the 20? Well, I'm going to slide that back up so you can see the image. And the height of 20 actually the width of 20 can be found by adding the two parts that we know together and then figuring out this missing gap. So that missing gap, I'm going to delete that. The missing gap has a length that's identical to the opposite side of the rectangle down here. So these parts both have to be 5 feet wide, which makes the total width pretty easy to find out because we can just add these three numbers up. So the total width of the object can be found by adding the 8, the 5, and the 7 for a total of 20 feet. Okay, and that goes all the way across the shape. All right, so on the chart, add that into the dimension. That's 20 feet by 17 feet. I called it region 1 on the picture just because it's the first region I found. So since it's a rectangle, rectangles are going to be base times height. So we have base is 20, height is 17 for an area of 340 units squared. Okay, but we've overcalculated the area. So I'm going to subtract out on the next two parts here the areas that we overcalculated. So looking back at the image, I'm going to call region 2 this part up top. I'm just going to kind of color that in red. Okay. Region 2 has a width of 5 feet, which I colored over, and a height of 6 feet. So down below, that's what we need to subtract out. Region 2 had a width of 5 feet and a height of 6 feet. Since they're all in feet, I'm just going to assume my answers are in feet squared. Okay, so rectangles again are base times height. So 5 times 6 is 30 units squared. And I'm subtracting that out because we overcovered it with region 1. Okay, so if you're using crayons and highlighters, this is where you can kind of keep your work nice and organized. Trust me, as these shapes get more complex, you want to keep them organized. So I'm going to choose my next hole to be green and just kind of shade that in. Again, I overcalculated that when I put the black rectangle on top. So we're going to subtract that region out. The area of that region is base times height. So region 3 is 3 units wide and 2 units high. Rectangles are base times height, so 3 times 2 is 6. I keep wanting to put units instead of feet. 6 feet squared. All right, that takes care of the entire right side of the picture. The left side of the picture is made up of several other objects. Now, I'm going to put that rectangle back on just so it's less confusing. We found the area of this region. Okay. We subtracted out regions 2 and 3, mainly because those regions were not originally colored in or filled into the picture. So region 1 is the big thing. Region 2 and 3 get subtracted out. The only pieces that we have left to cover up are, trying to find a triangle tool here. Only pieces we have left are the triangles and the rectangles on the left. So I'm going to choose a new color. If you're using colored pencils, you can do the same. Oops. Let me see. Slide that back. Okay. So we're going to use the pen tool. Make that purple. Now I've done regions 1, 2, and 3. I'm going to call this region 4. And with a different color, I'm going to highlight the bottom section and call that region 5. Okay. Notice the bases of these regions, which I'll highlight here, are the same dimension. So how do we figure that out? Well, I'm going to look down here. And the green rectangle we found in region 1, if you look down below, the green rectangle had a base of 20. So down on the bottom edge, we know this dimension had to be 20 across, which means 20 plus something has to add up to the 35. So 20 plus what is 35? Well, if you subtract those two, you'll come up with 15, which represents the base of that the base of the rectangle. It's also the base of the triangle. So regions 4 and 5, I'm going to draw down below. Region 4 was my triangle. These are not getting subtracted out because they are they didn't cover anything up that wasn't originally part of the picture. 15 units across, 17 on the hypotenuse. We don't know the height. And the rectangle was 15 units wide, but we don't know the height there either. So we really can't get the area of either of these yet because we're missing the heights. However, Mr. Pythagorean theorem here can help us figure out the height. So off to the side, just going to move this over. We can use this right triangle to do Pythagorean theorem to get the height. So I'm going to set that up by doing a squared plus b squared equals c squared. My hypotenuse is c, and that's across from the right angle. So we're going to do h squared plus 15 squared equals 17 squared. H squared plus 225 equals 289. I'm going to subtract 225 on each side. h squared is equal to 64. And if we square root that, h is 8 units high. So that means the height here is 8. So now my triangle is just base times height divided by 2. So 15 times 8 divided by 2 should give us an area of 60 units squared. And again, that's not getting subtracted because we didn't cover up any holes. So 60 feet squared, excuse me. Okay, the last region that we need to fill, we're still missing the height. So if you look back at the picture, let's figure out what we know. We just figured out the height of the triangle was 8. We know from this edge over here that this entire dimension is 17. So that leaves my rectangle here with a height of 9, because 8 plus 9 adds up to 17. So if I scroll down, I now know the height of region 5 is 9, which means since it's a rectangle, we can take base times height, 15 times 9, and that's 135 feet squared. Now if we add those up, I'm going to add all the positives first. So 340 plus 60 is 400, plus another 135 is 535, and then I'm going to subtract out the negative. So I have a total of negative 36. If I look at these two values from above, if I subtract out those negative regions, I'm left with 499 units, or excuse me, feet squared. And that is the area of that region. Your assignment is to try this same process on the next page. My suggestion would be to think about placing a giant rectangle. Oops, let me get my rectangle tool. Placing a giant rectangle over this whole region, and then subtracting out, okay, hold on. So giant, there we go. Giant rectangle, giant triangle here. Okay, that would be your total area, but you have to subtract out, oops, you got to subtract out this little tiny hole that's 6 feet by 3 feet. So that region down here will have to get subtracted from your total. Good luck. Show it to the substitute when you're done. You will receive a homework grade for what you accomplish in class today.